This video is all about picking your soldering equipment, choosing a soldering iron and using it. And the good news is that with the availability of Chinese soldering irons these days, the price, they've become really affordable for really good irons. But let's start off with the iron that I've used for decades. This is the Antex XS25 and I have used this to death. It's been my main iron. And this is what's called a thermally balanced iron. It doesn't have any temperature control, literally. You plug it in and it gets hot, and it takes a while to heat up because it does rely on what's called thermal balance. It doesn't have accelerated heating and temperature sensing. All it does is it pumps 25 watts into this heating element here, and that heats up the fairly chunky bit. And when it reaches about, I measured it, about 380 degrees centigrade, then the amount of energy being put into it is the same as the energy dissipating, more or less, and it balances off at that temperature. And I quite like it. It's a punchy iron. It's got good oomph, if you could put it that way. I choose a fairly big bit because most of the soldering joints I do are sort of fairly chunky ones. And because it's got a fairly large mass, it pumps out a lot of heat. However, I did find when I was really at the peak of my manufacturing, it sometimes couldn't quite keep up. And particularly in the larger joints, I had to actually do the solder joints in a particular sequence that it would be small joint, big joint, small joint, big joint, just to actually let it recover thermally between each joint. But it's been a good iron. And I recently switched over to using a Chinese soldering station, generic Chinese soldering station from eBay. And the reason for that wasn't because I was totally disappointed with the Antex. It's the fact I was struggling to get the bits I wanted for it. I have a particular preference for a 3.2mm bit. I think this one is chisel bit, and I wasn't finding them. The only place that I could get them off the shelf was Maplin in Glasgow, and they didn't stock them as individual bits. You could only buy it as a pack of 3, and they were mixed bits, and they weren't, you'd get the bit you wanted plus 2 others that you didn't want, and it cost 15 quid. And I thought, well, let's, for this video I thought, what is the price of an Antex these days? It's astronomical. To buy this soldering iron is the best part of 30 quid, and that's, Maplin's price was £28, and that was with the PVC lead, not the silicon lead like this one. It was the cheaper PVC, stiffer and more burnable lead. And then you look at the price of the bits. They're £5 each on those packs of 3 that I needed to buy to get the one I wanted. It was £15, and it's things like the spare element for it are like £13. And you suddenly realise that it's, compared to the Chinese stuff, it's not actually holding up too well. And for some odd reason, I mean, I used to just have this sitting at the back of the bench. I'd come into my workshop, switch the on button, the light would come on, the soldering iron would come on, everything would just power up, and the soldering iron would just sit there hot, ready for use all the time it was there. And there were even times that I went away on a job somewhere and came back 2 weeks later and discovered that I'd accidentally left the soldering iron on, and it was fine, no damage to the bit at all. It just, just clean it off and it was fine. Latterly, I had a major problem with the bits just pitting almost instantly. You'd go away, do something, you'd come back, and you'd be thinking, that's a new bit. And, I'm still using the ordinary lead-based solder that I've always used, and it's actually damaged already. And the design of these bits is they tend to be a thermally conductive metal like copper, but with an iron coating so that they don't corrode away too quickly, so they last a long time. And as soon as that iron coating's broken through, they'll just pit all the time. You can clean them up. You get cleaning stones for them, and you can burnish them off and then bring them back up to shine. They'll take the solder again, but then they pit again. And it just made me think, let's try one of the Chinese soldering irons. So I did. I decided, after a lot of shopping around, to go with the Yihua 8786D, and that's the one that's also got the heat gun. And it's not perfect. It's good, but it's not perfect. It's got some little annoying quirks. It's not got the punch that the original Antex iron had, because it just simply has lower thermal mass. And it's also not got fantastic coupling between the little heating element in here and the bits. The original Hakko it's based on has little sleeves that go around, and I don't know why the Chinese copies don't actually have those sleeves. However, once you've got used to the fact that, you know, you're going to have to bump the temperature up a bit, until I ended up just turning it up and using a proper thermometer to measure soldering irons. I just turned it up to the same temperature as I was used to working with, 380 degrees centigrade, which might sound a lot, but I find that's just the one that's just matches the speed I solder at. You may find that you can operate at a lower temperature. It really is a matter of feel. Soldering is very much a matter of feel. So let's do some soldering basics. Where's my notepad? I'm going to be taking a look inside another cheap soldering station after this, but in the firstly I just want to show the basics of the soldering, and I know that a lot of you guys watching will already be familiar with soldering, but this is for those who aren't familiar, and just to make it clear that, you know, it's not hard. It's really, the basics of soldering are very simple. If you've got a circuit board with a pad on it, and the hole in the pad and the component lead coming through, then when you solder, you do not carry solder you don't put solder on the iron and then carry it over and blob it all around it like glue. It doesn't work like that. What you do is you place the soldering iron against both the lead and the pad, and you heat them both up first. And this all happens very quickly. It's like you go onto the pad, flow the solder, off with the soldering iron, should I say, onto the pad, flow the solder, take the solder off, and then the soldering iron off, and then just leave it a moment and it cools. And it's really the only way you can learn how to do that is just by getting get some circuit boards, even some old circuit boards, and just reflow some more solder onto them and play about. Play. That's the only way you're going to do this. So what you do is you put the soldering iron onto the lead and the pad. You apply the solder, take the solder away, and then the soldering iron away, and it will cool down. And when that happens, the first thing that happens is that when you put the solder on, is the inside of the solder itself has a core. You use flux cored solder, and it's just a little round core in the middle. I know this because I took a bit of solder and I cut it off very cleanly with actually I used the Xuron snips because they do produce that really flat cut at the end. It's not pointy, it's very good. And it let me actually look with a microscope up the end of the solder, and there was a very obvious white core up the middle of the flux. And what happens when you apply that on, you'll get the sizzle and you'll see the sort of clear liquid run out, and that's the flux melting. And what it does is it cleans the surfaces, it prepares them basically for the solder, it flows over all the surfaces, and then the solder melts and then it flows over. And when you've made your joint, what you should get afterwards is this perfect sort of curve up to the component lead as the solder flows up. And there's a sort of general slight join there, and it should be this lovely, perfect joint. Again, I always recommend lead-based solder. If you can't get lead-based solder, then that's unfortunate. You won't get as shiny and perfect a joint as with the lead-based solder. Lead-based solder is not toxic, it's perfectly acceptable. It's only banned in manufacturing these days. So I'd recommend lead-based solder, and because it just provides a much better joint. It's much easier to use. It's perfect for learning with. If you get a bad solder joint, it will be pretty obvious. You'll get what's called a dry joint, and it will look like this. It will look a bit like an apple. A big blob with your lead coming out like that, and it may look a bit matte and crusty. And what's happened there is there's been no flux. That's the sort of joint you're going to get if you carried solder over. And as if you melt solder onto the iron, all the flux boils off, and then you carry it over. There's no flux there to actually mate it onto the leads. This can also happen if the leads themselves are tarnished beyond recovery, and in that case you'd have to clean the leads and try and reflow it. But when that happens, it's possible for the lead to be passing right through that big ball of solder without actually making a connection. It can lead to electronic problems. It can lead to just physically no connection between the pad and the lead. And it's very hard to see that. So you're looking for that perfect wicking, sort of little volcano-y type effect. Now, I did buy, just because I wanted to see how different it was, I bought flux-free solder. I bought this just to try out, just to see what effect it had. It is 60-40 solder, 60%, I think that's 60% lead, 40% tin. And it's just horrific. It really is impressive. If I ever get a proper microscope set up, I'll show you me making a solder joint with this, because it just doesn't stick at all. It just forms the balls every time. It really needs that flux. And for particularly tricky situations, you can get flux pens and extra flux. So, that's the basics of soldering. As I say, the only way you're going to learn, now I've told you that, now you know how to do it. Place the soldering iron on, heat the pad and lead, apply the solder, take the solder away, take the soldering iron away. That's all there is to it. And after that, it's trial and error. You know, you'll find that as you do it, you'll just naturally get to know how much solder you need, how much time with the soldering iron. It really is, it's just a matter of feel. And the only way you're going to get that feel is with practice, actually doing it. Building small kits, probably messing up your first kits. If it's any help, I completely destroyed my first kit when I was a kid. When I made it, it was such a disappointment. It was so little to destroy. It was a sort of 2-transistor oscillator that flashed 2 lamps, and I still screwed it up. Oh well. But that's the gist of it. And you'll also, once you've discovered how to solder, you'll find there are certain materials like aluminium that do not take solder. Stainless steel does not take solder. You have to use very special brazing or soldering materials for those metals. But this is something, again, that you'll find out as you do it. So let's take a look at a cheap Chinese iron. And here's one that I bought recently, just basically for this video. It's you could pretty much ignore the WLX. It's a 936 soldering station. That's all that really matters, 936. And there's a new one which I've just ordered, which I'll do a video on when it arrives, and it's the digital version of this. And this is just a nice, simple 24-volt station. Comes with a basic soldering iron stand, basic soldering iron, and you can set the temperature on the front. And first thing to know is the temperature calibration is way off. So there's 2 things you can do about this. You can go by feel, particularly if you're used to soldering. If you're new to soldering, that's not so handy. But when you first get it, I'd suggest setting it around about the 200, 250 mark and seeing if the solder melts and flows properly, and then just nudge it up until you get it just perfect to your exact feel. You could get a temperature unit. They do seem to use these quite widely in the factories. This is a soldering iron thermometer, and ignore the name Hako again. This is a clone. You can buy these on eBay. If you type in Hako 191, you'll find them. They're about £10. Not essential. You don't absolutely need this, but if you're into soldering, if you're already experienced in soldering, then you will find this quite a useful thing, because basically speaking, there's a little crimp in here, and you wet the iron with solder and touch it onto that, and it tells you the temperature of the bit. And it's very good. I tried before with a standard thermocouple. This one is rated to go up to quite a high temperature, and the results were very unpredictable. And that's also one of the things that kind of made me a wee bit wary initially about the Yehua, because when I tried calibrating it with the ordinary thermocouple before I got this one, it was very hit and miss, and I ended up getting it. I ended up turning the calibration knob, which is always sort of under. There's a little calibration hole that you can put a thin screwdriver through and adjust. I should mention the digital one. It's done by the buttons in the front. We'll cover that when I actually get it and try it out. But I managed to miscalibrate it quite badly, and get the whole tip of the iron was glowing red hot, just that dull cherry red, and then I burnt out the element, and that kind of like, oh god. So really the way I'd recommend it is if you don't have the proper thermocouple system for measuring it, just start low and just nudge it up until you get to the good temperature, but don't go by the scale on these. I have a feeling that you can buy the irons quite cheaply, I'll cover that shortly, on eBay, and they're thermocouple based, and I thought, well, a K-type thermocouple is a K-type thermocouple. it appears that that may not be so accurate. There may be some variation. The calibration may be essential. However, taking a look at this, let's open this. So the soldering iron unplugs in the front. It's got a little 5-pin connector. The original Hackos had a male plug, and these ones have a female plug. And I think that the original Hackos may have had a thermistor as opposed to a thermocouple. There's another good thing I should cover. What's inside the heat elements in these? So let's take a look in one of these irons. Let's just grab one of these from the pile. This one will do. If you look inside these generic soldering irons, then you undo this little sort of collet type thing and the sleeve comes off, and then you've got the bit. The bits that are dirt cheap, I should cover that as well, shouldn't I? There's so many, this video has got so many directions it could go. And then the construction is such that you don't have to take those off, but then you can unscrew this. And when you do that, a circuit board slides out. This bit stays together. You've got the heat element, the circuit board inside, with the cable just pulling right through from the back of the iron, and a crimp that grips the cable and also crimps onto the circuit board. And you can change these bits. You can buy replacement heat elements. But why would you want to do that when you can get the complete soldering iron with a bit, the soldering iron handle and the connector and everything? You can get that for £2 from eBay. £2 frickin' pounds. Bear in mind that just the bit for the Antex iron was £5. For £5 I'd expect to get this from a British seller, the whole iron. I mean, it varies. £2 to £5 is typical for these. However, so you could change the heat element if you wanted, but it's almost no need. So here's the construction inside. The yellow wire is connected onto this spring and it provides the earthing to the tip. And the good news is that most of these little low voltage irons do have a properly grounded tip. That's good. You've got 4 connections that go in the back, and from the heat element, you've got the thermocouple, and you've got the two. The thermocouple are they're coloured red and blue, and you've got the heat element itself, which are covered in the clear heat resistant sort of sleeving. And if you were to open one of these heating elements up, it's quite an ingenious design. I know this because I did open one up. I actually covered that in a previous video, but you know what, I can recap it here very quickly because it's really impressive. A really impressive construction indeed. So on goes the bit, on goes the little cover, screws down, job done. Now, inside these soldering irons is clever. There's a ceramic rod. This is the heat element bit with 3 holes. And what they do is, these holes are just 3 perfect holes that go right down the full length of the ceramic rod. And 3 wires come up them. The first wire that comes up inside is for a thermocouple, and then basically the thermocouple is a joint between its 2 different wires, 2 different alloys, with a little spot weld on them. Oh, where is it? Here it is. This is a thermocouple. It's basically a junction between 2 metals. Above a metal, with the 2 wires just joined together at that blob. And that's what this thermocouple is. There's a little blob, the little thermocouple blob, and then the 2 wires going down inside. And they come out the bottom. So that's the temperature sensing dealt with 2 of those holes. Then out the outside of this comes another wire onto the heat element, and then it spirals round and then goes up and down the other hole in the middle to insulate it, and then the whole lot has a separate, another ceramic sleeve slid over that, and it's all filled in with ceramic cement, and that's it. It's very clever. It's also worth mentioning that you can't really solder or easily connect onto these heat element wires. It's just an alloy that doesn't lend itself well to soldering or stuff like that. So what they actually do is, if this is the heat element, at the end they just take the same wire that's used as heat element, but they just twist it with another wire, and that makes the connection. They twist it for quite a run. In the case of this one, the twisting starts pretty much here, and then it goes right down the middle with the twisted wire. In the case of this one, it's the twisted on here, and it goes down. And they also put a little loop round and twist it onto itself to actually hold the element in the position. It's all very clever. So that's the heating element. That's basically what's in this. Very clever indeed. Right, where do I go from this direction? Right, okay, we've taken the heat element to bits, we've got the irons to bits. Let's take a look at the bits themselves, because you can get a pack of 10 for £5, and okay, there are a whole medley of different bits, some of which you might never use, but you can also buy individual bits. And my favourite one is a 900M-T-3C, and it's the chisel bit with a fairly high mass. The high mass I prefer over the pointy bits, because the pointy bits are better suited to maybe surface mount components, and also these ones have, because it's a larger chunk of metal going up to the end, it just carries more heat faster. And these ones I got a pack of 5 from an eBay seller called Seller Bible. Anybody who buys electronics will know Seller Bible. They're quite a bit more expensive than most other sellers, but they do sell interesting, fairly good quality stuff. So I got a pack of 5 of my favourite bits for about £3.50, so not that expensive really. And these ones were probably, it seems to standardise round about $1 each, an American dollar each is the sort of pricing structure of these bits. So that's the bits covered. The irons, another thing that's worth noting is that, I think I mentioned this before, the fact that the Chinese clones, if you're buying a replacement iron, make sure you get the right type that's going to go onto the connectors here, because they do the two type. They do the female and the male version of the front panel and the matching version of the iron, and obviously 2 females ain't going to go together, 2 males ain't going to go together, so you have to get the correct type for your iron. I'll bring the notepad in here and show the connections in here. So we get if you look down the end of the plug, you'll see there's a little aligning indent here, a little sort of traditional DIN plug, a German standard I believe, and it's got the 5 pins, or 5 holes, and the way it's got the element is connected across these two. If you're looking up the end from here, that's connected to the earth, and this one is leading up to the thermocouple in the actual soldering iron, so that's the thermal. So you can actually determine which type of soldering iron you've got, if it's got the thermistor or the thermocouple, usually by probing about in these terminals, but all these ones I've bought, these ones with this female one, have had the thermocouple, which is absolutely fine. I did, out of interest, buy a Hako element, and I'm pretty sure this is a thermistor in it instead of a thermocouple. It just measured somewhat differently. It's not going to be compatible, I don't think, with those irons at all. Right, let's see if we can finally get into this unit. Screwdriver. Now, this soldering station costs something like 22 quid. The price seems to vary dramatically, and it also seems to be very much supply and demand. But for that money, you get this base unit with the electronics. You get the soldering iron stand and the soldering iron. Is that going to come off? Yes, that's going to come off. Here's the construction. First things first. A big transformer in this one. This one has a chunky transformer. Note that the earth connections are crimped on, and they go past the transformer through the lamination stack, and then it goes onto the circuit board directly onto where it's going out to the middle pin to the soldering iron, so there is earth continuity all the way to that. There's a little switch circuit board on the side which has a position for a fuse, but it's not actually used in this one, which may be because it's the British market one, which doesn't actually need the fuse because we have fuses in our plugs. A bit strange though, that. And off that, it's just basically, it's a marshalling connector. It's got the little switch, it's got live and neutral in, and then going out to the primary of the soldering iron, the transformer, and then onto the circuit board. And look at this. Most of these contain a little module like this. You can buy these modules for £5. It's just really they're so common and so popular. But this one has a different one. This one has a completely different arrangement. I'm kind of tempted to take this off. I think I will later on take this off because I want to see what's on it. This one's different in the sense that some of these ones, they just use a basic op amp to measure the thermocouple, and it's a bit sort of random. Certainly the Yahoo one I use, it pulses on and off very randomly. This one doesn't. I don't know if this is using a little microcontroller or something, because this one just seems to vary the mark space ratio. It seems to cycle on and off in a very fixed speed, but the on to off ratio seems to vary. So I think they've maybe just stepped up to a better design here. Yeah, I really have to get that off at some point, don't I? The downside is that to get these ones off, you unfortunately have to desolder that connector, and it's a double-sided board, so that's not necessarily going to be pretty. But testing this, well, actually, you know, is this just going to fit in as a direct replacement? Will it be compatible? Oh, it does. That's interesting. So you could just completely swap and just use the transformer. If you knackered it up completely, you could just buy one of these cheap modules and swap it in. That's quite neat. But having tested this one, I've actually found it to be quite good. It's very quiet for a start. The other one, the Yahoo buzzed, it would make a bzz, bzz. You know, it's a distinctive noise. You've probably heard it in the videos. This one is quiet. It's really quite nice, actually. I just noticed that turn there. No, it's tight. It was just me using excessive force against it. The quality, for such a cheap unit, it seems to be pretty good. Not really that much else to say about this because, you know, apart from the fact... I should remove that circuit board, shouldn't I? One moment, I'm just going to remove this circuit board. I thought this was not... I thought it wasn't going to be based around the op amp that the other ones are. I thought it was going to be based around a microcontroller, but it is, in fact, an LM358 op amp they're using in this. So that's interesting. For reasons of transparency, I had to kick out the Antex. That was the only way I could get this connector desoldered from this circuit board, and it's down to thermal mass again. The little Chinese arm would be great for doing all these solder joints over here, but when it comes to big things like connectors, sometimes you need a bit more oomph, and that's where something chunky like this comes in handy. However, that's the first time I've had to kick that out in ages, just for this task. But interesting to note that thermal mass is quite important there. Also interesting to note this is just the traditional M358. That's neat. This one uses something similar, but it's the through-hole version. All they've done is make the circuit board smaller here. Looking forward to the digital one arriving. I have to say that the digital one, I ordered it recently, well, literally about an hour ago, because I was doing my research for this video, just looking up how much things had cost and where they're available from and how things had changed, and saw that was the latest model and thought, you know, that'd be interesting to take a look at. But here we go. It's fundamentally it's the triac that switches the element, as most of these do. They just switch the AC supply from the 24-volt transformer, comes straight up, goes through the triac. What is this triac? Is it going to be visible? BT136, very common triac. So it's being switched by that little dinky transistor probably, which is being driven from the op amp, which is measuring the thermocouple, and just comparing it. But I'm guessing this, I think this is an LM358, that's a dual op amp, isn't it? One's probably being used as the sort of comparator, and the other one will be used as the amplifier for the low signal from the thermocouple, because it's just literally millivolts comes from that, and then it will compare it to the voltage that this is set to, plus this calibration knob will just skew that slightly. So neat little circuit board, very, very small. I'm just going to put that right back in now, and then I'm going to put this together and we'll test it and we'll do some soldering with it and see how well it fares. Okay, that's it back together now and running again. So I like the fact you're going to see a slight flicker here off the LED because the LED is it's being pulsed at sort of mains frequency because the soldering iron runs on 24 volts AC and the LED is basically just across that with a diode and resistor, so it's only sort of lighting a half wave. So I don't see the flicker here, but I do see it just cycling on and off in this really nice, smooth, rhythmic manner. Nothing really, no randomness. It's a very decisive on-off. This is set for 300 degrees centigrade. The calibration is just a mile out, as I would expect if we put a wee blob of solder on here. Oop. And put it on there. It's about 375 degrees centigrade. So yeah, that's not 300 degrees centigrade, so it's very much a matter of just fine-tuning it to your own preference. So let's solder some components onto a printed circuit board. Now this is the point it's worth mentioning, that I use two sizes of solder. I use the thick solder for bigger joints, like say for instance I'll probably use it for this terminal block, which is 18 SWG, SWG meaning standard wire gauge, so 18 SWG, which is about 1.5 millimeters-ish thick. I'm not sure. Let's go and get the, let's measure that actually. Let's be scientific about it. So here's a gauge, let's reset that to 0. The wire, the thicker wire, the 18 SWG, is approximately 1.15 millimeters thick, and the other wire that I most commonly use, it's much thinner, is 22 SWG, and it's approximately 0.73 millimeters thick. And initially I'm going to be using the, what is that, the 22 SWG. So let's try soldering some components in. I'm happy with that temperature, so I shall be using that. Now, here's another thing, the soldering iron stand, this is quite a snug, tight fit. Let's, just out of interest, let's try one of the other irons in it. I'm pretty sure the other one that I loosened up, and that's not bad. I think this one's just got a wider rubber cover on it. Could be tempted to loosen that up just so it comes out easier. I prefer to snatch it without the station coming with it. It comes with this foam pad, which you're supposed to make wet. Let's just move that out of the way first and tip this up. Get that out. I don't use the wet foam pad anymore. I used to use it all the time. It used to be the main sort of means of cleaning the tip, but now of course I use this sort of brass spongy sort of I mean, you find these in dollar stores. It's a brass scrubber for pots, but that actually, it's very clear that this is a repurposed ashtray that it's in, but it's great. It cleans the tip without abrading the tip too much and takes all the solder off. And when you take this out, it's got lots of tiny little balls of solder in it. So that's what I use for cleaning the iron. However, let's start soldering some components onto this random circuit board that's just not going to achieve anything particular, but I'm just actually testing it to see how well it solders. So there's a diode. I put my favourite tip on it, the bit. Yep, that feels good. Yep. Let's try an IC socket. This just hums very slightly, and that's all. It's actually quieter than the other unit. I'm getting envious. I might actually end up being tempted to use this one because it is so much quieter than the other one. And so more decisive. That little LED cycling on and off is so much more sophisticated than the other one, which just tends to be a wee bit random. So as always with the IC sockets, I solder 2 diagonal pins first. Here's this technique again. I do it really fast, so maybe you won't see it so much, but I put the soldering iron, touch both the pad and the lead, apply the solder, and then take the soldering iron away. And as I say, if you're learning soldering, it's just a matter of playing and doing this. You'll get the hang of it very quickly. It's not that hard. I was taught to solder in one go by a chap called Nathaniel Benson, my old science teacher, my physics teacher at Hunter High School. He just basically said, here's how you solder, and it was just like, that was it. From then on, I could solder. So let's try something beefier. Now, when I put these terminals in, I like to just hike the leads up, just make sure they sit up snugly, because these are rising clamp terminals, and they're going to be using the thicker solder for this. This is a much larger mass device to solder. And it's handling it absolutely fine. Let's see how it holds its thermal mass, holds its temperature. I'd say it's falling off a tiny wee bit with the larger connections, but not that much. It's still perfectly acceptable. It is somewhat telling that if you do watch those videos that I mentioned on YouTube that show Chinese production lines, there's one in particular channel, I can't remember what it's called, but he walks along the production line, just tours factories and walks along it, and it's just rows and rows of people making stuff manually. And it's notable that a lot of them are using these very same soldering irons, and you go, oh, that's that 936 clone soldering iron. So it's if it's good enough for the Chinese, it's good enough for me. Let's try some switches. This is one of my own little RGB controllers. I designed it absolutely ages ago. I designed it before. It's based on a design before even the existence of a company called Color Kinetics, who unfortunately patented the concept of RGB control of LEDs with pulse modulation. It's just very odd patenting system, kind of screwed up the whole LED industry for a while. I beat them, but unfortunately, because I didn't think it was something that you could patent, I didn't patent it. That would have been quite useful, but having said that, I still don't think it's something you could patent. That soldering iron is perfect. It's absolutely fine. So for 22 quid, it's a decent station. It's actually quite nice. It's solid. The transformer, I felt the temperature earlier on after being running it for a while. It seemed fine. It doesn't seem to be stressing the transformer. It cycles on and off nicely. It's quiet. The soldering iron, you can just buy new soldering irons and just plug them in. If you could even, instead of changing bits, if you were prone to using multiple bits, you could actually just have a soldering iron per bit, although the calibration might vary a wee bit. But, you know, on the whole, I would say that's actually pretty good. Now, is there anything else I want to cover here? I'm trying to think here. I've covered solder, I've covered the bits, the ready availability of all the bits. You know, that just about sums everything up. It is actually a good soldering station, you know, for general sort of hobby use. It's absolutely fine. Even for professional use, I'd consider something like this. Certainly the Chinese seem to think it's acceptable for professional use. The only place it falls down is in really high mass solder joints, but then most soldering irons do. And that was demonstrated by trying to get the back off this connector, where there were just so many big pins taking the heat away through a double-sided board, which made it somewhat more complicated, because otherwise I've tried to clean the solder off, but that just makes it a wee bit harder. That's the only time that that's the first time I've had to dig out the big chunky Antex iron in a long time. And generally speaking, if you've got a lot of huge solder joints you have to do, then it's worth getting a dedicated soldering iron just for those joints, and then just using the more delicate soldering iron for the finesse. Other things worth mentioning, if you use, as I do, this chiseled bit, you'll find the cable by default, it usually is supplied curled up, rolled up, basically like this. So the cable wants to fall in a particular direction. You want to, while it's cold, you want to actually adjust it so the face of the soldering surface where you're going to be mating is in the correct direction when that cable falls down that direction, just so that you're not working against the cable. And as I say, you'll just get the feel of it. You'll naturally just choose to do this later on when you've been soldering for a while. So yep, get yourself a soldering iron, get some kits off eBay, and start soldering. Now I'm going to do one more test, so I'm just going to pause momentarily while I do that test. Okay, I've just completed a little scientific experiment. I left this set at the calibrated value, well, not the uncalibrated value of 300 degrees centigrade, or Celsius, as some people prefer it to be called. Same temperature. And I tried all the irons in it and gave them a good time to heat up, and used them while they were heating up. I used them to solder the rest of the circuit board up. The iron that came with it, at the 300 degrees centigrade, setting here was 358 degrees centigrade or Celsius. The iron I normally use, the Yahuwah iron, was 354 degrees. The spare one was 326 degrees, spare 2 330 degrees, and the spare 3 was 341 degrees. So you do have to calibrate it to each iron, although it may be a type K thermocouple in it. It does have that variance between them. Other things worth mentioning are the length of the leads. By far the longest leads was my usual one, the Yahuwah, which was 36 inches. This one comes with a 34-inch lead, and the other 3 spare ones, the cheapies, came with 29, 28 and 29-inch leads, which are still perfectly acceptable if you've got it sitting next to you on the bench. I don't know if I mentioned it, the compartment I normally use that actually comes with the foam pad. You're supposed to make this wet and you're supposed to clean the iron on it, but as I say, I prefer using this. If you don't use it as the sponge pad that you soak, and as soon as you soak this it puffs up and then you can wipe the iron on it, it cleans all the solder off. If you don't use it for that, I use it for storing the spare bits in. So, in synopsis, in summary, these are fine. These Chinese soldering irons, I've been using one for a while now, and for general small electronic assembly like this, they're absolutely perfect. You know, they do the job. They're not maybe as fast as the higher thermal mass of professional irons, but for general use, hobby use and professional use, light professional use in many applications, I'd say these are absolutely fine. So I'm looking forward to the digital one coming. I want to see how that's calibrated. I've got a feeling it's got 2 buttons in the front, the digital one, the 3 7-segment displays, and then up and down, which I'm guessing is just up and down of the temperature. Plus, it says calibration in the middle, so I'm guessing that you press both to put it into calibration mode, and then just nudge it up or down by whatever difference it is. So I'm not sure yet until I get that. So yep, I like this. It's very good. So far, and these irons, you know, they're a very simple design there, and the fact that you can get the bits in a multitude of different styles for basically $1 each. What can I say? Go and buy one and start building stuff.